My name is Jitendra Thakur. Currently, I'm pursuing a course on Coursera platform, AI Product Management, which is offered by Duke University. So, I'm recording this video as a part of the first assignment, which is related to creating a model to predict the electrical energy output of a power plant. So, in this project, as you can see over here, there are five parameters involved. One is temperature, then the ambient pressure, relative humidity, exhaust vacuum, and the energy output. So, first four of them are being the input and which are independent variables or the parameters, and electric output PE is the dependent variable or the output parameter. So I have divided this data set into two categories. One is training set, which accounts for 80% of total universe, and other is test, which accounts for the 20% of total universe. But first, before I go into model, I would like to show you the correlation matrix of all the variables. So as you can see over here, there is a high positive relationship between the temperature and the vacuum. Which is 0.84, and there is high negative relation between energy output and the ambient temperature. And the ambient temperature. Okay, now I would like to move over to how I created this model. First I will explain you, and then I'll show you my output. So basically, as I said, I have divided this data set into two categories, which we normally do: training and the data set, so which accounts for 80 and 20% respectively. I have created two models. First model is which include all the parameters in all four parameters, and as well as one output parameter. And there is another model which I created, wherein I have excluded the RH, which is relative humidity, to calculate the matrix. Along with that, in order to determine the error matrix, I have calculated the MAE, MSC, and MAPE. So model which I used to determine the matrix is multilinear regression model, because there are multiple independent variables involved, which is determining the outcome of the dependent variables. So as you can see over here, for the first model, so R square method. So I would like to compare both models and then the test dataset model to make an interpretation. So R square is very high if you compare it with the model 2 outputs. So for model 1 it's 0.98, sorry, 0.92, and for the model 2 it's 0.91. So similarly, if you compare the error matrix, so MAE, it's 3.61 and 20.52, and uh, um, MAP being 0.79. So if you see, all three error metrics are on the lower side, uh, and as compared to the model 2 as well, the values are lower, which means our model is working as expected and there are no outliers to it. Along with that, if I compare this model with the test data results, so if you see, our results are on the similar line. I can see R square similar to the model 1, so which reaches to a conclusion that we are good to proceed with model 1, and our model will give us the appropriate results. With that, I would like to stop my presentation. Thank you.